3, 2, 1, go. And we're live. This is Retraice segment number 104 for Monday, January 2nd, 2023. Retrace is about what's going on out there. The short answer to that is computer control. We are in the second day, day 2 of our deep dive into AIMA4e, day 2, chapter 2. I don't know if I explained this yesterday on day 1, and I'm not even sure I had completely decided it by the time of the live stream. But I'm just doing a fast reading of each chapter for each day in January. There are about 28 chapters, so we'll have a little over that in 31 days to read 28 chapters, and just to get the whole thing into our... Because the idea is, if we're going to do a degree in 2023, or our equivalent of a 4-year degree in a single year, Q1, which is January, February, March, has to correspond to year 1 of undergraduate school. And so we have to get through this book, the first pass of this book, really quickly, and then we have to start focusing on projects and blah, 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 all this stuff. Anyway, that's our study strategy right now. And so let's talk about, well, we can't talk. Okay, so chapter 2, big, major, fat correction. This is terrible. To the table-driven agent series. I said a million times, unfortunately, that the agent function was the part of the agent program that sort of made the agent program smart. So in table-driven agent, I was saying that the agent function was the table. That was just an error. Because I was jumping in just to do the code and the math. I sort of derived a definition from... Anyway, it doesn't matter. I misunderstood the definition of... Look, agent function is just a mathematical description or mathematical abstraction of an agent, and agent program is the implementation of that mathematical function. Where's my thing here? I will read you exactly the way that I've corrected, and I've put this correction on everywhere that's relevant, the YouTube videos and then the notes wherever it's mentioned. So the agent function is not the smart part of the agent program. The agent function isn't, and I'm quoting AIMA, as I should have been doing from the beginning. The agent function is an abstract mathematical description that maps any percept sequence to an action. The agent program is a concrete implementation of the agent function running within some physical system. So function is a math, program is code. It's easy. It was a dumb mistake. I had this idea in my head, and anyway, that's what happens when you're not an expert and you're talking about stuff that you don't really know about. It's what we talked about with the bottom-up versus top-down. But top-down learning is very goal-oriented and motivating, but the problem is you often have words that you don't have any way of understanding how to use, or you have to use words that you have no way of understanding. There you go. Prime example, and I paid dearly for it. It's a pain in the butt to go back and make all these corrections in the PDFs and all this stuff, but it's done. And we're moving on. Okay, and the reason it comes up now is because I realized it on page 1, the first couple of pages of chapter 2, which is where table-driven agent, or where that idea comes from, the agent program versus agent function. All right, so let's talk today about I think the most important idea in chapter 2 is this creating a model of the what's called the task environment and then the environment of the task environment. So they have a little acronym PEAS, P-E-A-S, performance measure, environment, actuators, and sensors. Is it actuators or is it? It's actually, yeah. Jeez, see, I'm checking now. Yeah. So A stands for actuators. So down here I've drawn a little agent. The agent's got its sensors and actuators, and it's in an environment. Where's the performance measure? I'm not really sure where I should draw this. Like, is it part of the agent? Is it part of the environment? I think it might depend on how it depends on your task environment and how you implement an agent program, but we'll come back to that. The environment, though, the aspects of the environment that can be distinguished and described are what make the difference between like really hard problems and really easy problems. The more constrained the environment, the easier it is to build an agent to be successful at pursuing a goal or doing whatever you want. Maybe it's just a reflex agent, not a goal agent. Observability, agentness. Okay, so let's talk about these things. Observability is either partial or full. Agentness is either single or multi. Determinism is kind of the one that takes a little bit of getting used to. So if it's it's a deterministic environment. If the current state plus the action determines the next state, and that applies to all agents, not just your agent. So if it's multi-agent, then the current state plus the actions of whatever agents determines the next state. That's deterministic. Stochastic has explicit probabilities assigned to states or future states, and non-deterministic describes the possibilities, but does not assign explicit probabilities to those numbers. That's the way they use it. Okay, this is not the best paraphrasing, but it's good enough for now. Episodic is sequential. Episodic. Are you making one decision, or are you making a series of decisions to achieve your goal, or given any percept? Staticity, is it static, semi-dynamic, or dynamic? Dynamic is like when things can change even when the agent doesn't act. Semi-dynamic is, oh crap, I forgot what it is. It's somewhere in between. It's like it's like when there's a cost or something to not acting. And then static is just nothing happens in the environment unless you do something, and so it's the simplest of the three. Discreteness, are you talking about discrete numbers or continuous numbers, basically, the real line, or like the real or the whole numbers, the integers, sort of distinction. Unknownness, this one they say is not necessarily part of the environment, so they don't really necessarily include it in their on page 47 of their description of environment characteristics. But it kind of should be there, shouldn't be there. They acknowledge that it's kind of a gray area, I guess. And it's the agent or designer's knowledge of the laws of physics of the environment. They put it this way. Strictly speaking, this distinction, talking about known versus unknown, strictly speaking, this distinction refers not to the environment itself, but to the agent's or the designer's state of knowledge about the laws of physics of the environment. If in a known environment, the outcomes or outcome probabilities of the environment is non-deterministic, shouldn't they say stochastic if it's probabilities? Anyway, do not take my corrections of them at all seriously. So in a known environment, the outcomes or outcome probabilities of the environment is non-deterministic. For all actions are given. So in a known environment, the outcomes for all actions are given. If the environment is unknown, the agent will have to learn how it works in order to make good decisions. The distinction between known and unknown environments is not the same as one between fully and partially observable environments, et cetera, et cetera. So anyway, known versus unknown, it's a nuanced concept. I'm not really there yet. Same with determinism, like stochastic versus non-deterministic. But then going back to our drawing, or let's just finish with this. Actuators and sensors are parts of the agent part of the environment. So they're over here. So, you've got but now this distinction, so this, I'll just read what I wrote. The sensory inputs of software, so let's first talk about sensors and actuators of our agent. We're talking about software agents. There are other kinds of agents that they describe. They talk about robotic agents. This is on page 36. And I guess that's the only kind. But anyway, there are different kinds of agents. We're dealing with software agents in this world. The sensory inputs of software agents are file contents, network packets, and human input via mouse, keyboard, etc. Software agents act on an environment by writing files, sending packets, and displaying information or making sounds, that sort of thing. And then the environment. This is crucial. How do we the whole universe is an environment. Which part of it is an agent? Which part of it is the part that we care about? The environment can in principle be the whole universe, but in practice, it's only the part that affects what the agent perceives and what is affected by the agent's action. Okay, so that sort of narrows our. And then at the top here, let's talk about task. So they say on page 42 to 47, task environments are in a sense, they're the problems to which the agents are the solutions. Labeling entities as agents as opposed to artifacts. So we're calling this an agent, not just this isn't a hand axe, right? This is something more complicated, more interesting, but it's sort of it's not an absolute distinction. Labeling entities as agents as opposed to artifacts is a tool. This is the way they put it: a tool for analyzing systems, not an absolute characterization that divides the world into agents and non-agents. AI operates at the most interesting end of the spectrum, where the artifacts have significant computational resources, and the task environments require non-trivial decision making. Okay, so that's how we should think about the sort of soft distinction between agent and environment, and the relationship being sort of problem solution. Environment is the problem, agent is the solution. Obviously, that has like philosophical implications, like why is the environment such a problem? But it's just this is technical stuff for analyzing systems. We're collapsing into specialization. We're narrowing our focus. Blah blah blah. But I think I talked about I don't remember what segment I talked about it, but the important idea is this thing is like this AI is a way of thinking. I was trying to figure out last night what are we going to call AI literacy? You've got regular literacy, letter. Does the etymology of that word go back to the word, or is it connected to the word letter? I bet it is. If it's not, whatever. I'm not going to go dig it up. I'm not going to go bust out Oxford etymology for that. And then there's numeracy, number literacy, and then there's code literacy. I don't know if they've got a clever name for that yet, but this is not code. This is not code. Code literacy is prerequisite to, I think right now it is anyway, prerequisite to AI literacy. But AI literacy is like a different way of thinking about the world. It's a very useful way of sort of carving up and reorganizing the world and categorizing, like what we're looking at here. What's an environment? Oh, it's just where the place where things are, man. No. It is a thing that has OADES-do characteristics. We have to. What kind of environment is it? Is it observable or fully or partially with respect to us or with respect to an agent? How many agents are in that environment? Is it deterministic or stochastic or non-deterministic? Is it episodic? With respect to an agent, is it static? Is it discrete? Do we even know the laws of physics? Blah blah blah. This is a way of thinking about the world that's new. That's just the last 50 to 70 years, and it reorganizes things. It changes. I think it changes a lot. It's definitely changing the way I think about the world and problems. I mean, we even talked about changing state from outsider non-player to insider or to player, not necessarily insider, but player in the computer control game, and formalizing that. We started to formalize it. We're not done with that, but sort of turn that using strategies for formalizing problems to formalize our problem, to make it more tractable, to talk about states and actions, to compose our state space and actions available at each state, and the transition model and action cost function and evaluation function and objective function and all this stuff. This is a different way of thinking about the world. Are people of the future not going to think this way? I can't imagine that they're not going to tend to think this way. The same way today, people don't do arithmetic with Roman numerals in their head, and they don't think in terms of sticks laying on the ground or drawing in the sand to do their math. They really can just think about the number 1, about the number 5, about the number 0, which was actually a late innovation in the history of numeracy. I think this is going to be, if you go talk to people in the future, the entities of the future, whatever they're going to be, hopefully they're going to be our descendants, but I don't know. Only if we win the game, so to speak. The concepts they're going to use are like this. It's going to have to do with this. It's going to have this sort of stuff at its foundation. That's what I think anyway. That's okay. Day 2, chapter 2. That's it. This has been Retraice segment number 104. Back to the normal time tomorrow, 10 p.m. Eastern, 7 p.m. Pacific, and notes will be at retraice.com, retraice.com, and anywhere else you can click through to them, the YouTube description and the RSS feed. All right, that's it. Signing off.